Hello, my name is Steve Goodwin, and this is my anchor test video number 118. Today we'll be reviewing this Kingston Quickset 50. It did come out at 50 pounds on my scale, and when in the setting position, the tip was 11 pounds for a tip to total weight ratio of 22%. Now last week we reviewed a Quickset 22, and its tip to total weight ratio was 33%. So what's going on here? Why does this anchor have a substantially lower ratio or amount of its weight on the tip? And I think the answer is in the fact that the shank is wider than it really should be if we were to just sort of scale things up linearly. Now, for the engineers out there, they're going to want to double check all this. Let me just go over some of my theory. We know that if we double the length or the linear dimension of an object, the surface area will go up by the square, and the volume or the mass will go up by the cube. Now, this anchor weighs more than double the other. It's actually about 2¼ times heavier. So we will take the cube root of that, and we come up with a linear dimension of, should be about 1.3 times as big. However, the width of the shank is 1.7 times as large. So it's pretty clear that they've needed to increase the width of this shank to make it strong enough. I'll also mention that the length is less than what we would expect. In two ways, this shank is stronger, and indeed, this shank did not bend during this week's test. Last week, you'll recall that the Quickset 22 ended up with a bent shank during my reversal tests, and this one did not. Now, I compared the smaller Quickset 22 to the Excel number 2 on the bench last week. I bolted everything down, and I was in the process of straightening out this anchor. I went ahead and put a slight bend in this anchor, and just by measuring the force required to bend these in this direction, I determined that the Excel was a little more than twice as strong, or it took twice as much force to get a permanent yield on the fluke. Now, this week, I'm not going to do any of that pulling. I'm going to use mathematics, and I've done all the calculations. I've measured height, width, and length for both anchors, and just so you know, I'm calculating that the width affects strength by the square, meaning if you doubled the width, it would not be twice as strong, it would be 4 times as strong. The other dimensions are linear. If you double the height, it gets twice as strong, and if you double the length, it's twice as weak. You got a longer lever arm. Those are my theories behind the numbers. And if I compare the Quickset 50 to the Excel number 5, they both weigh 50 pounds, similar arranged anchors. Do all the math and all the calculations. If they were to use the exact same grade of steel, this anchor should be 1.3 times stronger. Again, it's getting that strength due to it has a really wide, thick plate, and it's pretty short. However, the Sarka Excel number 5 is the shank. It's made out of bis alloy 80. That's an Australian grade of steel, and it has a yield strength up around 600 MPa. The Quickset 50 is made out of 304L stainless steel, and its yield strength is only around 200 or 210 pounds. So if we use 3 times stronger metal in the Excel, I calculate that in theory, this anchor should take 2.3 times the stress or sideways deflection to get it to yield or permanently deform. So there was 2 things that I found fascinating if we compare these 4 anchors. And the first is that in both cases, between the smaller and larger, the Excel anchors were a little over 2 times stronger in terms of bend resistance than the Quicksets. The other thing that's interesting is both manufacturers felt it necessary to sort of boost the strength of their larger versions, but they used completely different ways of doing it. The Quickset folks, they used thicker plate, whereas the Anchorite people, they just used stronger metal. As I stated last week, the smaller Excel uses a 350 grade of metal, where the Excel uses steel that yields up around 600. I'll mention that Kingston sells their stainless anchors in 2 versions, a commercial finish and a highly polished finish. They sent these 2 anchors to me in one of each. The 50 had sort of the commercial sanded finish, whereas the 22 was very highly polished. As I noted last week, after testing the 22-pounder, that really high luster did go away, and the two finishes are really quite similar now. I'm sure a bit of elbow grease would bring that high luster back, which makes me think, gosh, I guess if you wanted to save a few bucks and wanted a highly polished anchor, maybe you could get out the sandpaper and the rouge and polish out a commercial finish and make it shiny as well. In terms of their chain attach hole, Kingston has provided a very generously sized hole, and virtually any conceivable shackle will fit just fine. This is a 5/16 shackle, which is too small for this size anchor, but it fits perfectly, and everything on up to and including a 1/2-inch shackle will fit just fine with no binding. I'll mention that the profile of the shank means that this anchor has a tremendous amount of self-launching power. We'll know a few months back I set up a rig here on the bench to simulate a foredeck with a bow roller on it. I put all the anchors on the bow roller and connected a length of chain, and the idea with the test was to see how much chain a stowed anchor can drag or deploy on its own without having to give it a kick. And I can tell you this anchor, again, the shape of this means that it has a tremendous amount of self-launching power. All right, that's enough shop talk. Let's get out of the water and see how the anchor does.
Oh, here we go.
We'll start things off with some reset testing in the sandy mud with short chain, only 12 feet of chain. And a real common result of using short chain in these reset tests is you get complete pullouts or backflips rather than rotations in the seabed as the boat passes over. We saw that initial set was real clean and instantaneous, and sure enough, the first reset was a backflip. The anchor self-righted and dug right back in. The second reset, same thing, another backflip. Took a little longer to right itself, but once it did, it just dug right in. I'll give you this last one here that I'll show you in slow motion. Yeah, same thing. It releases, is upside down, but self-rights and digs right back in.
The anchor did good, 100% of the time. 10 resets, all good.
Next is another 10 resets in the same sandy mud seabed, but this time with long chain. And I've stated many times in previous videos where I've noticed that with long chain, anchors tend to rotate in the seabed, and the short chain, they tend to do backflips. Well, here we see a backflip in spite of the long chain, and unfortunately, the rest of the 9 resets were obscured by seaweed on the camera, so we don't get to tell exactly what happened here, but I think there is a good indication that this anchor tends to not want to rotate in the seabed. And when we get back to the workbench after these water tests, we'll talk a little bit more about that potential phenomena.
Okay, the Quickset 50 was 10 for 10 on the long chain reset sandy mud. Nice stops, held nice big bursts of power every time. Good.
And with a quick look at the latest ranking chart, we'll see I gave the Quickset 50 a 4.5 out of 5 in the 180-degree reset sandy mud column. That's the one on the far left. The anchors that got a 5 in this category, they really could not be moved more than an anchor length or two away from their original spot. It's truly amazing. Those anchors were just stuck like glue. And then the worst anchors, they would foul up with mud and maybe not reset at all.
Okay, we've got the Quickset 50 here in sandy mud, 8-to-1 scope, long chain. The dead man was already set really hard. We got a 5,000 pound pull out of the M2, so any movement will be the Quickset.
Okay, as stated, we're still in the sandy mud, but scope's up to 8-to-1 scope. This is sort of a resistance check to see how much pulling resistance the anchor can make up against a winch. We are pulling against a dead man anchor, and as I said, that anchor had already been used to test a Mantis M2 up to 5,000 pounds, so that anchor, that dead man is fully set, and we don't. That's good, because we only had about 30 feet of pulling road left over. I am pulling on the dead man anchor road, so the test anchor road is remaining at a constant 8-to-1. We saw a peak of about 1,500 pounds there toward the end of that pull, and then it was stable at about 1,000. Now I've got a snatch block in line for the final 15-foot segment of this pull series.
And that made all the difference. Previously, I could only get up to about 4,000 pounds of pull with this winch, and even then, it was really struggling, and I imagine it would burn up quickly. But with this snatch block, we've effectively doubled our pulling power. There is some friction given the nature of this style of block, so maybe we haven't doubled it, but maybe it's only 30 or 40% more. But that's the difference that we needed, and we're going to see here, we're going to get up to, or right next to 5,000 pounds, and the motor keeps moving reasonably well. Note that the bow of the boat is slowly moving downward. We're up into the 3,000 pound range now, and I can now see a bit of the water over the bow of the boat. And indeed, the whole boat is being pulled into the water, but the bow is pulling down at a faster rate than the stern. That's actually good. There's more freeboard up there. That's just the nature of the way I've got this rode up over the bow roller. And then the rode out the stern that has the test anchor, it's attached right near the transom. So it's putting a sort of a moment, a pitching moment to the boat. And again, the bow's coming down faster. And there again, we got a pretty good view of the water. And sure enough, we're up to 4,200 pounds. No, it's not a lot of really speedy motion. It's only moving, you know, you can see the main line there moving a couple inches per second, and then the roads are maybe only half that because we are pulling with a snatch block. You can see those numbers creeping down when the motion has stopped, so it's extremely difficult for me to tell you what a non-motion holding number would be. It's a matter of how much time you want to wait, but I've let it set for many minutes, and it just slowly keeps moving downward. These numbers are really large. Boats that would use a 15-pound anchor, if they were seeing a steady 3,000 pounds of pull, this would be a tremendous amount of wind. I'm not going to speculate on how much. That would be dependent on the style of boat and how it reacts to the wind and waves. But again, I've stated before that the main purpose of these numbers is not to try to figure out exactly how much holding power your anchor will make. It is to compare the holding from one anchor to the next. And now we're back underway with some motion here, and right back up 4,500 pounds, 46. Again, this is the final feet of this anchor rode that I have available to me, so it was pretty lucky that we got right up to the maximum, or near the maximum. 5,000 is my cutoff point, and we touched 4,900. So I think if we kept pulling on this anchor, we would indeed see 5,000. You may recall from last week's test of the 22-pound Quickset anchor that it was able to hold or resist 2,900 pounds, and that was with the same 8-to-1 scope, but no chain whatsoever, just Dyneema. So it's completely reasonable to assume that this 50-pounder will make even more than the 4,900 that we saw here today. Here's a look at the peak pulling resistance chart. The far left column, sandy mud, 8-to-1 scope, long chain winch. That represents the test we just saw. The bottom number there, 4,900 plus, that one is the Quickset 50. In the light blue in that same column, we have the Mantis M2. I mentioned that it did 5,000 pounds. It was actually going up when we came to the end of the rope, so it has a potential for more. Then we also see in red there the Excel number 5, 50-pounder. That one actually maxed out at 4,000. And numbers actually went down from that point. So that truly was a peak for that anchor. But all these are very, very high. Obviously, if we look over in the soft mud, the numbers are much, much lower. And of course, the cobblestone on the far right, very, very low numbers there as well. So yeah, sandy mud is generally a very high holding seabed, provided that the anchors can remain engaged and not foul up or roll out. Next test is a veer in the sandy mud, and the protocol for the larger anchors in this test is to use a rope-only rode at 7-to-1 scope. It's a little easier for me to handle these anchors without the chain.
since I don't have a real dedicated windlass for hoisting these anchors, so it does make my life a little easier, and we do get a look and see how anchors perform without chain. In any event, this anchor does extremely well during the initial veering portion of this test. And when I say initial, I mean the full 180 degrees, the anchor just stayed put. We are watching this footage at 8 times playback speed, and boy, there's just not a lot of motion. In fact, I don't see any motion. The camera's tethers are just stuck right there. At some point, the camera does plunge downward. We're still during the veering portion. But then somewhere along the lines about here, the veer stops and the boat, the engine power has increased incrementally, and somewhere around 1,000 pounds of pull, the anchor did a real quick release. And my assumption is that during the veer, the anchor developed a list. I have no way to verify it because it was completely buried. So, like I say, around 1,000 pounds, the anchor did release, but it did reset perfectly, and then held the full thrust of the test boat.
Okay, that was a good veer. Didn't detect any motion during the veer. Did have a real quick release and then reset on the final straight line ramp up.
And with another look at the ranking chart, third column over from the left there, the Veer Sandy Mud, I gave the Quickset 50 a 4. The couple other anchors were better, Excel number 5 and the Spade S100. Viking 20 also was real good with a 4.5. Those anchors really didn't move much at all throughout their veer or the straight line portions. Next is a straight line holding power check in the Cobblestone seabed. Use lots of scope here, lots of chain, shooting for basically infinite scope at the anchor. There's not going to be any chain lifting with these low holding numbers that we get from this seabed. This anchor does pretty good here. It doesn't spend a whole lot of time dragging. It attains the upright attitude and gets that toe dug in multiple times. And for this test, the numbers I give, the holding numbers, really are a true holding number. And for this seabed, it's a little different than the others. The maximum holding numbers are achieved when it is not moving. If I bump the power up to the point where it starts moving again, the anchors always break out, every single one of them, and then have to start all over and reset again. And this one just does the same thing. And what I got was several times it held 285 pounds with no motion, and then I had one really good 315 pound hold. And if we look in the far right column, we'll see that 315 is about average, maybe a little less than average. The real standout here was the 51 pound Viking. In light blue, we see it at 840 pounds, which is far higher than the next best, which was the 45 pound Mantis M2 at 500 pounds. So at 315, we'll see the Quickset 50 is not among the worst anchors, but it's at best, we'll call it middle of the pack.
Okay, we got the Quickset 50 here in Scow Bay. 25 feet of water, 200-foot rode on the test anchor. It's a winch test. It's the first 15 feet. Feet. Okay, I'm gonna let that set for 10 minutes. Okay, that's a 10-minute dwell after the second 15-foot segment for the Quickset 50. The water's real still here, and we're holding steady at around 250. Been steady there for the last 5 minutes. So we'll give it the last pull now. Okay, third pull, Quickset 50 Scow Bay. Okay, fourth 15-foot segment. Pretty steady there. Gonna call it good. And there's 22. 24, and we are moving. Okay, it's the Quickset 50 here at Scow Bay. It's the second try and we now have a set. We are not moving. We're at 2,800 or 535 pounds, and I'm going to start a veer. I'm sensing quite a bit of forward motion. There is, yes. And it let go, 2 knots.
Okay, we just watched the second of 5 attempts at conducting the veer in the soft mud. That one we just saw, it released at the 70-degree mark during a 535-pound baseline pull during the veer. This, the third attempt, it released just as I got to 535 pounds, so we didn't get any veering in, and then it did not reset. By the way, on all 5 of these, once the anchor released, could not get it to reset. So this anchor appears to mud foul or foul in some way that it just will not reset after release. Here's the 4th attempt, and on this one it released in a straight line at 395 pounds. So that's even worse. And at this point I thought, well, we're just going to have to downgrade thrust, and we'll try to do a veer at 395 pounds.
Quickset 50 soft mud veer, reduced thrust, 395, 5-to-1 scope, 25 water, 125 road.
You can see here on deployment that quite a bit of chain goes out before the camera goes in, and it's about 20 feet. I put the camera 20 feet away from the anchor, and that's just to keep it out of the mud. Sometimes even that fails. But this anchor doesn't penetrate much, so we never had any camera fouling. But we do get a good view. It held this 395-pound veer all the way through 180 degrees. So we finally got it to perform, but again, it did take quite a bit less thrust than many of the other 45-pound range anchors. So that was a good veer, and then after 180 degrees, I straightened the motor out and ramped up power, and it was solid at 535 pounds, but at 620, it started dragging and then eventually released. And once again, it would not reset. Okay, last test will be a veer check in the clean loose sand. Notice that the anchor had to sort of spin around there on the initial set, and it executed that no problem, dug right in. Baseline pull for this seabed veer is 860 pounds, and it achieved that no problem. First half of the veer was real solid, didn't move much of anywhere, but at some point around the midpoint, the anchor developed a bit of motion. I think I could sort of detect a lump off to the side, so maybe the anchor was listing a bit. And there we see, there's that motion I was talking about. We are watching this at 8 times playback speed to keep the video a reasonable length. But finished off the veer just fine, and then the straight line portion during the ramp up at about 1,100 pounds, right there, we saw the anchor rose up and partially released, but then immediately reset, and then right up at the max pulling power of 1325, there was just the slightest amount of motion. Last look here in the middle of the chart, we'll see that I do not have numbers populating the columns. Gonna wait until I get all those X's filled in. But for the Quickset 50, we see the soft med veer. I gave it a fair. Clean sand holding, excellent. That's kind of dubious because when I start winch testing here, the numbers are likely going to get much, much higher. But in any event, an anchor that doesn't move much gets an excellent. And then in the clean sand veer, I gave it a good. It did have that bit of motion. The very best anchors just stayed put and didn't really move far at all. Okay, so early in those 180-degree resets, I mentioned that this anchor has a tendency to flip over backwards rather than rotate on around in the new direction. And I think it's pretty easy to see why that is. The anchors like this will have a large vertical distance here, or vertical height in the toe of the anchor. This one has almost a flat sort of a face that has to be forced sideways through the seabed if it's going to just rotate around. Other anchors that have a real thin fluke, many of the roll bar anchors are like that. It's pretty easy to see that something flat can slice through the seabed much easier than something that's flat and more vertical. Now, the good part about an anchor with a fluke or toe with a large vertical dimension is strength. Many times a flat fluked anchor will be lodged under something immobile like a large stone or other debris. Then you go to retrieve the anchor by lifting straight up and the toes will bend down. An anchor like this, that's basically going to be unheard of. The shank will be the weak link at that point, yeah, you're just not going to bend those toes down. So this is just another example that anchor designers face. It's just a trade-off. You're going to get one thing and give up another. Okay, let's take one last look at the ranking chart. On the far right columns, those are the non-performance categories. First, price. I gave it a 4, and for a stainless steel anchor to be head-to-head against galvanized anchors and come out near the top, that's really saying something. So that's a really good value for a stainless steel anchor, and not having to worry about galvanizing. Wow, that's a pretty strong point. Engineering and strength, I gave it a 3. That's just based entirely on the theory that this shank is maybe, say, half as strong as some of the stronger anchors. Again, galvanizing and corrosion gets a 5 because there is no galvanizing. Tip to total weight ratio was a 2, a little on the low side, and self-launching power is a 5. It just doesn't get any better. Total average was a 3.9, which puts the anchor, you know, up near the best anchors, certainly upper middle of the pack. So I've been showing you those ranking charts now for quite a few months, and if you remember early on, I was pretty careful to give kind of a disclaimer, and I'm going to do that again, just a repeat. And it's just simply, don't take those numbers too seriously, in that the rankings that I give and the amount of weight that any particular column gets, you know, that's subjective. You may be in an area that doesn't have cobblestone for 500 miles, so that column means nothing to you. Or maybe you think of some other column that should be weighted heavier. And then again, maybe there's columns that are completely missing. I mean, I don't have any hard sand, so you could certainly inject sort of your own ranking column from someone else's anchor tests, and you come up with a whole new set of numbers that's based more on your personal value systems. Okay, that's all I got for the Quickset anchors. New test anchors keep streaming in. Got an 18-pound Danforth high tensile, Here's a 9 kilogram or 21 pound Vulcan anchor. That's going to be a real good fit for these other 20 pounders. And I picked up another Fortress. This is a little bigger. The other Fortress I've been using is an FX16. This is an FX23. So lots of good stuff coming. Of course, I still need to fill in lots of X's and blank spots in those ranking and pulling power charts. So I'll be very busy for the rest of the summer. I always appreciate the donations. You can click on the links down in the description to my PayPal and Patreon accounts. Everybody else who's just watching and supporting me in any way that you can, I really, really appreciate it. Okay, till next time, anchor safely, and I'll see you later.